All right, so we're going to take the data that is on the function table to graph that onto that graph. So we're going to need to create our ordered pairs first. And again, our inputs are our x values and our outputs are our y values. So our first ordered pair is going to be 130. Then I have 260, 390, and then I have 120. Again, I'm going to have that same problem looking at this graph. My x values are fine because I picked low numbers. My y values, my outputs are going to be a little bit too small. So I'm going to go ahead and change these. I'm going to alter these a little bit. I'm probably still not going to make them all fit on there. I'm just going to add a 0. I'm going to multiply each one of those by 10. So it'll be 10, 20, 30, 40, 50, 60, 70, 80, and 90. And let's go ahead and graph those. Our first ordered pair is 130. So our first number tells us left or right, and that's positive. So we're going to move to the right one. And then we're going to go up to 30. Our second ordered pair is 260. Again, that first number tells us left or right. So right 2, and then up 60. And then we have 390. So right 3, and then up to 90. And then 120, so I go up 4, and then 120 would actually fit off of our graph right there. And then as best as I could, I would connect those. And this is going, or it would be going in a straight line. And so this would be considered a linear function because, again, it's a steady increase. It just keeps going up in the same direction, the same pattern. So what would it look like if it was not a linear function? Anything that curves or loops around would be a not linear function, or if it went a little bit and then suddenly it went big and then straight and then basically if it had like different movements. This is a steady increase. Each time you move to the right once, you go up 3. So that would be a linear function. All those ones in the red would not be linear functions. Oops, I can bring back that one.